Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is Palindromic Substrings. So the problem statement goes like this. Given a string S, return the number of palindromic substrings in it. Okay, so a string is a palindrome. For those of you who do not know what a palindrome is, a string is a palindrome when it reads same backward and forward. What the problem statement mean by this is, let's say the given string is A, B, C. This is forward when you will read it in left to right direction. When you will read it in right to left direction, then it will be CBA. So these two strings are not equal, so this is not a valid palindrome. Let's say the string would have been ABA, then if you read it left to right, then it would have been ABA, and if you read it right to left, it would have been ABA again. So these two strings are equal, so this particular string is a palindrome. Okay, so this is what a palindrome is. And it's mentioned that those of you who are not familiar with what substring is also, then it's mentioned that it is a contiguous sequence of characters within a string. So let's say string is A, B, C, D, E, F. Then a substring in this particular string can be this, or this complete. Okay, so B, C, D is a substring, C, D, E is a substring, A, B, C, D, E, F is a substring. But if let's say you take A, C, then you are missing B here. Okay, so it is not a substring, it's not a contiguous part of the string. Okay, so this is what a substring is, and let's see the constraints of the problem. So the constraints are like this, that the length of the string will be of order 10 raised to power 3, and it is mentioned that there are only lower English letters in the string. So you have to return the number of palindromic substrings. Okay, so let's see how we'll be solving this particular problem. For that, first of all, we will be considering a brute force approach. Okay, so for finding a substring, you will be requiring two things. Let's say this is the string given to you, and you want to find a substring. You should be knowing that where you will be starting your substring first character and what will be the substring's last character. Okay, these two pointers should be known to you. Let's call this left, and let's call this one as right. Okay, so combination of left and right will determine what a substring will be. If let's say you mark the indices of this string. Okay, so in total, if let's say the string is of length n, so in total order of n square will be required to make all the combinations of left and right. Okay, so n square combinations. After that, let's say you will be getting a substring that is B, C, D, E. Okay, now to to check this particular substring whether this is a palindrome or not, okay, you will be requiring order of n time complexity. Why is it so? If let's say the size of this particular string was order of, okay, was n, then order of n will be required, because what you will be doing is you will place one left pointer here and one right pointer here, and you will move them in this direction, and you will be comparing each character. So whenever a character is not equal on right and left pointers, then you will be returning false. So all in all, you can say that brute force will take you order of n cube, where n is the size of the given string. Okay, let's say this is the string given to you, then n is the size of this string. And if you see in the constraints that this n is of order 10 raised to power 3, so 10 raised to power 3 raised to power 3 it will be. Okay, so it will be 10 raised to power 9, and this 10 raised to power 9 number of operations required is very much greater than not significantly, but it is greater than 10 raised to power 8 operations. Okay, and so these number of operations are a limit for every solution that you will be using. So this is the operation limit. Okay, so whenever the number of operations required by your solution to solve a particular problem exceeds or become equal to this operation limit, then you may get a TLE and your solution will not be accepted. TLE is time limit exceeded and your solution will not be accepted. So in order to get this solution accepted, we should be optimizing this solution. So optimization is required. Okay, so now we should be thinking that how will we optimizing this particular solution. So for that, little observation will help us in a very significant way. What that observation is, let's say this is the substring given to you. Okay, and let me take some other characters also. I guess this should work. B and C. Okay, just a second, let me let's say these are 1 2 3 for simplicity here, then it will be 3 2 1. Okay, and yeah, so if you see this particular part of, let's say this is a palindrome. Okay, so if you read it in this direction, it will be 2 3 4 3 2 1, and if you read it in this direction, it will be 1 2 3 4 3 2 1. Okay, so both of these strings are similar, so that's why it's a palindrome. If let's say you want to take this much part only from this string, then it will be 3 4 3. Okay, and if let's say you decide to take this much part, it will be 2 3 4 3 2. Okay, so both of these parts of a palindrome are also palindromes. Okay, you should be taking part of from the palindrome such that you are leaving equal characters from left and right hand side. In this particular one we were leaving this one and this one, and in this particular one we were leaving this much part. Okay, so both of you are making you can say equal cuts on left and right, both of the sides. Okay, so this is how we will be generating palindromes from a palindrome itself. Okay, so how many palindromes a single palindrome can generate? Okay, that is the question here. Okay, so let's say if you start at a particular index. Okay, first of all, there are two types of palindromes. One is of odd length and one is of even length. Odd length palindrome and even length palindrome. Okay, so even length palindrome can be 1 2 2 1. Okay, so it is of even length, it is equally divided. And odd length one can be 1 2 3 2 1. Okay, so this particular character is occurring in the middle, so it will be not be a participant in either the left half or the right half of this palindrome if you divide it in middle. Okay, so these are two types of palindromes there. So what we'll be doing is, we'll, for each index, let's say we mark the indices of this particular palindrome 0, 1, 2, 3, 4, 5 and 6. So for each index, what we'll be doing is, we'll be forming the number of palindromes that can merge out of this particular index as the middle index. Okay, or our index can be a middle index, or it can be divided into something like this. Let's say this is index, then either it can be a case that this one is your index and it is your index plus 1. Okay, so it is for the even length. Okay, you are starting from at least 2 length and then forming the palindrome. How are we forming the palindrome, if you may ask? We are spreading in both of the directions one step simultaneously. So one step here, one step here, then one step here, one step here. So these palindromes will be generated, but there is a condition that is to be satisfied. What this condition is, whenever you will be expanding, these characters should be equal. So whenever you are taking one jump on left hand side, that similar jump on right hand side should be having same character. Okay, and throughout this expansion that you are doing, all of the for every jump on left and right side simultaneously, this condition should hold. Okay, what I mean is, let's say it cannot be the case that you started from here and then you were having something like this, then you ended up on C and D, and then also you keep on continuing. Okay, so you cannot continue, you will terminate here itself, because these two characters are not same. So you will terminate, you will be having only one palindrome that is possible. Okay, so as of now we are not considering any character here, so there will be only one palindrome that will be possible. If let's say we are taking into odd length into consideration, then we will be starting from a single character and then we will be expanding. Okay, so we can easily count the number of palindromes in order of n square. Okay, so for each index we will be doing this thing. Okay, so it will be more clear to in the coding part what I mean by expanding by considering each index as a center, or each index as a, and one index after that as a length to string. So let's see the implementation, it will be more clear to you there. So this is the implementation. So for each index, for each value of right, or say index, while we are traversing from left to right, we will be considering two types of palindromes and we'll be forming them by expansion. We will be considering two types of palindromes and we'll be forming them by adding one character on both right and left sides of it simultaneously. Okay, and we'll be doing so till the both characters we are adding are equal. Okay, we will be doing so till both characters that we are appending simultaneously are equal, because if the characters are not equal, then it will not result into a palindrome. Here you can see that C A A D will not be a palindrome, so you will be terminating here itself. Okay, so whenever you see that these two characters are not matching, okay, so you will be expanding in this way. Okay, so one character to left and one character to right simultaneously. Okay, you will keep expanding. So this is what we are doing in count palindrome. We are moving left towards left and right towards right. Okay, and we are doing so till every character at left and right is equal, and we will simply be increasing the number of palindromes that are forming continuously. Okay, at last we will be returning this palindrome count. Okay, so what two types of palindrome are there: even length and odd length palindromes. Okay, even and odd length palindromes. So this particular operation that we are doing, it will always add two characters, so it will keep the length of the palindrome even always. So to make the difference of even and odd length palindromes, you should be doing the work here itself. Here you are passing the same index, so this one is for odd length palindrome. Okay, and this particular one is for even length palindrome. Since if you see that right plus right, two indices are there. Okay, so it will be starting from a even length, and this particular is starting from a odd length. Okay, so this one is for even length palindrome. Okay, and you will be simply be returning whatever the palindromic substring count is, and that is how you will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.